Hello friends, welcome to my YouTube channel. So today the problem that we are going to discuss is furthest building you can reach. Okay, let's read the problem statement first. So you're given integer array heights representing the heights of the buildings, some bricks and some letters. Okay, now you start your journey from building 0 and move to the next building by possibly using either bricks or letters. While moving from building I to building I plus 1, if the current building's height is greater than or equal to the next building height, you do not need a ladder or bricks. You can directly jump. Okay. Now, if your current building height is less than the next building height, then you can either use one ladder or the number of bricks which is equal to the height difference of those buildings. Okay. Now return the furthest building index you can reach if you use the given ladders and the bricks optimally. Okay. So I mean here the buildings are being shown, and yeah, here it is kind of yeah, these are is using bricks here, and here it is using ladders. Okay. Now let me explain the problem to you first. So this is kind of one of the example that I picked from here. Yeah. So this example I took it. So bricks are 10 and letters are 2. Kind of bricks are bricks are 10 and letters are 2. Okay. Now see, so these are the heights of the buildings, right? So if you see, this is of height 4, this is of height 12, this is of height 2, this is of height 7, this is of height 3. So in red you will see all the building heights. Okay. In green you are seeing the index of the building, or maybe you can say building number. So building number 0 has a height of 4, building number 1 has a height of 12, similarly building number 8 has a height of 19. Okay. Now the person is already standing here, right? The person is already standing, sorry. Okay. So person is already standing here at building number 0. Okay. Now if he wants to, so basically the question says that, okay, these are the buildings. He wants to kind of jump from one building to another, but he can reach from one building to another easily, or maybe without using a ladder, if the height difference is negative. For example, if he's sitting here, right, on this building, he can jump directly from there because the height of the next building to which he wants to jump is lesser than or equal to, here it is lesser than the current building height. So for example, he's standing here, so current building height is 12, the next building to which he wants to jump is 2, right? So he can jump directly. Otherwise, if the height difference is positive, for say right now, right, he's sitting or standing here on building number 0, then the height of this building is 4, and the building to which he wants to jump to, the height of the building is 12. So if he wants to go from 0 to 1, he either can use a ladder if that is available, or he can, I mean, place bricks till the height of the building will be equal to the height of the next building. So he needs to use 8 bricks in this case. Okay. Or maybe he can use one ladder if he wants to, if it is available, right? Yeah. So that's the question. So we need to figure out the furthest building he can reach. I mean, like he can move on and on and on, and he will reach a building. I mean, he's not able to move further. So we need to kind of help him reach the furthest index by using these bricks and ladders optimally. Okay. Now what does optimally mean here? Let's look at it. Okay. So if you think like here, for example, go from he wants to go from this building to the next building, right? He either can use bricks. How many bricks he can use? 8, right? I mean, he has to use 8 bricks if he wants to move from here to here, or maybe he can use one ladder. Okay, now which option he should choose? Let's see, let's go via if we always choose ladders. Okay, for now let's take a ladder. Okay, now let's see, he took a ladder, he reached the building. Now where he has reached, he reached here, right? He reached at this position. Now if he wants to go from building number 1 to building number 2, right, so he can directly go, because the building height of 2 is 2 and building height of 1 is 12. So from 12 to 2, since it's a height decrease, or maybe if the heights are equal also, then also he can directly jump. So he can kind of come after jumping here, right? He can directly come here. He need not use any bricks or any ladders for now. Now he wants to move now from this position to this position, right? So from building 2 to 3, so how many bricks he can use? What is the difference of the heights? 5, right? So he has to use 7 minus 2, that is 5. So he has to use kind of 5 bricks to reach from building 2 to building 3. Now let's say we are already giving priority to ladder for now. So since he has already used, so in the starting there were 2 ladders, but at this index he has already used 1 ladder, so we will decrement the count. So now the number of ladders will be kind of 1, right? So he has now is now available with 10 bricks and 1 ladder. Okay, now let's see from building 2 to 3. So again let's say he uses the ladder option. Okay, from here to here, again he uses the ladder option. Okay, so now how many ladders he's left with now? 0 ladders, right? He's left with 0 ladders and 10 bricks. Okay, now from building 3 to 4, right? From building 3 to 4, since the building height of 4 is lesser than the building height of 3, so he can directly jump from 3 to 4, right? So he can directly go here, he can come here, sorry, he can come here, right? He did not use any ladders or any bricks. Now for moving, if he wants to move from building 5 to 6, right, how many bricks he needs to use? 15, right? 18 minus 3, that is 15, correct? 15 bricks he has to use, but he's not having those many bricks in his hand, right? He's only having 10 bricks, but he need 15 bricks. Okay, 15 bricks here if you want to use from, I mean from this building to this building he want to go, so he need to place kind of 15 bricks to make the height of the current building equal to the height of the next building. So but he's only left with 10 bricks. So now he'll think, right, that somehow the ladder options that he had used, okay, so is there any ladder which he has used earlier can be replaced with lesser number of bricks? Okay, so you'll see, so this ladder, right, if you see this ladder, I mean how many bricks here, the so this ladder could be replaced with 8 bricks, right, and this ladder can be replaced with kind of 5 bricks. So which ladder is beneficial for him to remove? The one with the lesser ones, right? Here 8 are required, 8 bricks are required, here 5 bricks are required. So it is beneficial to remove this brick from here, or this ladder from here, and replace it with 5 bricks. Okay, and we can use this ladder at this point of time to reach from building 4 to building 5, right? So let's do it. I hope this, I mean, decision is clear to you. So what when I'm stuck here, right, when I don't have those many bricks with me and my ladders are gone, I now thought of, is there any ladder which I have used earlier? Can I replace that ladder with some bricks and I can use that ladder here at this point? Yes, I can replace this ladder maybe, because this ladder could be replaced with 5 bricks only, but this ladder could be replaced with 8 bricks. So it's better to replace the ladder with lesser number of bricks, right? Okay, Now keep this thing in mind. So we are kind of, if we want to keep track of the bricks this ladder could be replaced with, so maybe we will use this in while we think about the logic. Okay, I mean right now also we are thinking about the logic, but while writing the code, I mean it is more beneficial to decide which structure we can use, right? So okay, now what I do is I will remove the ladder from here. Okay, and I'll use this ladder here. Okay, I'll use this ladder here, and now how many bricks I need? So this ladder earlier, how many how many bricks it was replacing? It is replacing kind of 5 bricks. So I'll reduce the bricks to 5, correct? Because 5 bricks now are kind of placed here, right? Here 5 bricks are being placed, and the person can jump from this to this, right? So now I've used 5 bricks and 2 ladders till now. Okay, now let's see. Now we are at this building now, right? We reached at building number 5. So that person is standing here. Let me make this person's stand here. Okay, now if you see, if you want to jump from now building number 5 to 6, right? 5 to 6. So so again you will ask a question. So you need kind of 2 bricks here, right? 2 bricks here. Can you use, I mean, is there any ladder which you have already used earlier that could be replaced with less than, I mean, that you have used for less than 2 bricks, okay, which could be replaced by kind of less than 2 bricks, but that is not the case, right? So always when you make a decision that whether to use a ladder or not, you in the starting you kind of go with using the ladders first, right? Now when ladders are already finished, now whenever you have a brick requirement, you ask this question to yourself that whether the ladder that you have already been used earlier, so does any of those ladders can be removed from there and used here? So the decision will be on the basis of that ladder which you are removing, right? That is replacing kind of lesser number of bricks, so that, I mean, you can, and here you have a requirement of more bricks. So I hope that this thing is clear. So maybe, so here you have a requirement of only 2 bricks, but these ladders are already kind of using 8. So here it is 8 bricks, sorry, here it is replacing kind of 8 bricks, here it is replacing kind of 15 bricks, but here you have a requirement of only 2. So you will keep those ladders there only, and you will use kind of your bricks. So 2 bricks you will use here, so 3 are remaining. So by using kind of a 2 bricks here, you will kind of jump to this building. Okay, now from 6 to 7 you can directly jump, right? Because the height of 7 is 3 and this is 20. So from 20 to 3 you can directly jump and you will reach here. Now from 7 to 8, right, how many you are required? You required 16 bricks. 16 bricks, right? So is there a, I mean, ladder you can replace? So this is using kind of, this is replacing 8, this is replacing 15, right? Replacing 15. Now you need a 16. So this is 8, this is 15. So even if you will kind of use this ladder here, you don't have 8 bricks, right? You have only 3 bricks left. So I mean, you can't move further, correct? So you can only reach at index 7, building index 7. Now that's how, I mean, this problem can be thought of. Now every time you are keeping track of the number of bricks that ladder could be replaced with, right? So right now this ladder, right, this ladder could be replaced with 8, this ladder could be replaced with 15. So that, I mean, whenever you want to make a decision that okay, you are now finished with your ladders, you can think that the earliest ladders that you have used, I mean, can you replace any of the ladders with those many bricks and you can use that ladder here? If yes, then you will kind of remove it from there and use it here. Otherwise, like, I mean, that's how you're now when you're keeping that, making that decision, right? For example, which ladder you will prefer. I mean, for example, there are two ladders, right? This could be replaced by 8, this could be replaced by 15. So you will prefer the lesser number of brick replacement, right? Because I mean, this is replacing 15, this is replacing 8. So you will remove this one. This one you can use further. This you can, I mean, if you have kind of a, you are left with kind of 8 bricks and you can replace kind of this brick here, or maybe this, how do I put it? So let's think, for example, you have a requirement of say 16 bricks somewhere, 16 bricks somewhere. Okay, now you have this ladder with which can be replaced with 8 bricks, this ladder which can be replaced with 15 bricks. Now you will prefer using this ladder right over there, so that you only need 8 bricks in this case, correct? And 8 maybe you can put it from here, which you are left with, if you have those many bricks with you. I hope that is clear. So every time you need kind of a lesser number. So if you keep track of the, this ladder could be replaced with these many bricks. So, and you are putting that, so you are putting kind of 8 into a structure, you are putting 15 into that same structure. So you're always, that structure should return you 8, right? So there you can use min heap. So priority queue or min heap, right? Which will give you the lesser number of a ladder which replaces lesser number, which can be replaced with lesser number of bricks, right? So that structure will give you the ladder which can be replaced with lesser number of bricks every time, right? You started putting on the, whenever you place a ladder, you add that height difference into that particular structure and it always gives you the minimum. So that's a min heap kind of structure, right? So now let's try writing the code and maybe I'll explain you how, I mean, we'll use priority queue and all. Okay, so let's see. So priority queue will take, first of all, okay, this is priority queue of integers. Okay, and this will be kind of sorted in ascending order. Okay, now you can say let's return 0 for now just to resolve the compilation error. Okay, now we'll iterate over this. Int I equal to 0, I is less than head source length I plus plus. Okay, now we calculate the difference, right? So difference is height I plus 1 minus height I, right? If diff is less than equal to 0, then we continue, right? So that means we are moving from, say, building number 3 to 4, right? If we are moving from building number 3 to 4, then the height difference is 3 minus 7, that is negative. 3 minus 7 is minus 4, right? So that is negative. Or maybe if they both are of same height, say 7 minus 7. For example, the height of this building 4 is 7, then 7 minus 7 will be 0, right? So in case of kind of 0 or less than equal to 0, we'll continue, right? We don't need any bricks or letters. Now let's use the ladder for now. So if we, so what this priority queue, so ladder replaced with bricks. Okay, so you'll put kind of the difference, okay, here. So now kind of we used a ladder. Okay, now if the size of this is greater than the number of ladders, right? If size is greater than number of ladders, then what we'll do is we'll remove the ladder which will replace lesser number, which could be replaced with. We removed the ladder which could be replaced with lesser number of bricks. That's why we need, that's why we need min heap, right? Min heap, or maybe you have sorted it in ascending order, right? So I'll remove those. I mean, so this will give you kind of ladder, how many, I mean, how many bricks required to replace ladder, bricks required to replace ladder. Okay, those ladder I'll subtract from the bricks that we have, right? Okay, now if that bricks is less than 0, now I should return I, right? Otherwise I'll say if I'm able to kind of complete this loop, so I reached at the end, right? So I should say maybe height dot length minus 1, correct? I can reach at the end of it. Okay, so yeah, this is the code. So let me again like go through this code. So I took a priority queue, which is kind of every time I am placing a ladder, I'm adding a number which is this ladder is replacing how many bricks into this priority queue. Okay, so for example, when I'm using this ladder, this first one, right, I'm adding kind of 8 into it since it is replacing 8 bricks. Okay, similarly if I add this ladder which is from connecting the building 4 to 5, so I'll add 15 into this. So now as soon as I'm adding these, so now every time I use the ladder, but I mean as soon as the size of this, for example, I have kind of number of ladders as x. Okay, so the size will be, size of this will go kind of to x plus 1 at max, because every time if it is going beyond the ladders, that is x, so x plus 1 is greater than x kind of. So if it is more than x, so I'll remove 1 from it, so again it becomes x, right? I'll remove the ladder which will be kind of, which could be replaced with lesser number of bricks, and I'll remove those many bricks from the required bricks. And if the count becomes negative, that is, I mean, I don't have those many bricks available, so I mean I need to return kind of I can't reach the I plus 1th building, right? So that's how it is. Let's try. I equal to 0, I is less than, okay, it will be, since I am using I minus I plus 1, right? So I should take care of the index. Yeah, it is. Yeah, it is accepted. So this is one way of solving it. Another way could be like here I have given priority to always choose a ladder, and once the ladders are more than the available one, I'll remove one, right? Similarly, you can kind of start with, I mean, choosing bricks first, and then maybe if you are, I mean, short of bricks, then again you will remove those, and you can choose kind of priority queues of bricks for the bricks rather than ladders. This is another solution. Okay, so this is the solution wherein this is the problem wherein you have to figure out that at what building index you can reach. So furthest building you can reach, right? But if you have been asked a problem wherein, I mean, this height set is given to you, ladders and bricks are given to you, and just you need to return a boolean value that whether you are able to reach at the end or not. So think about that solution, and maybe you can share in the comments that okay, what would be the solution of in that case. Will you still prefer using the same solution? Because yeah, that could be solved by using this as well, but is there any easier solution that you can think of in that case? So you just need to return whether you are able to reach at the end or not. Yeah, thanks guys for watching. Please like, comment and share, and yeah, thank you.